My dear students, this particular session is for sure going to give you some 40 marks in just 10 to 15 minutes. So please and please be with me till the end. These are some short topics which are asked every year in your NEET examination. The first topic is heat and work. Second is the question related to graphs, question related to intensive extensive properties, question related to ideal non-ideal solutions, question related to solubility and solubility product, identification of oxidizing and reducing agent, experimental determination of order, and Gibbs free energy. And in this particular session, I'll let you know all these concepts in some 10 to 15 minutes maximum. Okay. My dear students, the first concept which is asked frequently in your examination. What is that? Before showing you that question, you should know first of all, whenever heat is absorbed by the system, Q value is taken to be positive. Whenever heat is released by the system, Q value is taken to be negative. Whenever system undergoes expansion, work is done by the system and W value is taken to be negative. And whenever a system undergoes compression, work is done on the system and W value is taken to be positive. Okay. Based on this particular thing, we can solve these basic questions. My dear students, the question is at STP, that means pressure temperature is kept constant. Pressure temperature is kept constant. Now, first of all, if you look at the first question, you have to check during this process, what is the sign of W? Whether W sign, whether work done is positive or negative in these processes over here. So let's get to know one by one. So first of all, on reactant side, how many gaseous moles we have? 7 plus 4, 11. On product side, how many gaseous moles we have? On product side, we have 6 plus 4, 10 gaseous moles. So when this reaction is happening, when the process is happening, what is happening to the number of gaseous moles? Number of gaseous moles are decreasing. My dear students, as per your ideal gas equation is concerned, PV is equal to nRT. Since pressure and temperature is already constant in the question, R value is already constant, I can say volume is directly proportional to moles. So during this particular process, moles are decreasing. And if moles are decreasing, volume will be decreasing. Decrease in the volume of the system is what you call as compression. And whenever there is compression, we say work is done on the system. And whenever work is done on the system, we say W value is taken to be positive. So in this particular case, you are going to take the value of W as positive. Number one. Number two, on reactant side, if you see, you have got gases. On product side, you have got liquid. So during this particular process, your gases are getting converted into liquid. And when gases are getting converted into liquid, that means molecules will be coming closer. If molecules are coming closer, volume of the system decreases. Decrease in the volume of the system is what you call as compression. Whenever there is compression, work is done on the system. And whenever work is done on the system, W value is again taken to be positive, right? Here in this particular case, solid is getting converted into gas. And when solid gets converted into gas, what happens? Expansion. Whenever there is expansion, work is done by the system and W value is taken to be negative in chemistry, right? So this is the first type of short question which is asked in your examination, my dear students. The second short question which is asked in your examination, you'll be given with these graphs, right? You'll have to check which temperature is more here, which temperature is less. Which pressure is more, which pressure is less. Which volume is more, which volume is less. For that, what you need to do? My dear students, as per your ideal gas equation is concerned, PV is equal to nRT, or I can say P is equal to nRT divided by V. This question can be asked in physics as well. Now, what I need to do here, understand what I'll be doing. First of all, I'll be drawing a straight line, okay? After drawing a straight line, I'm keeping basically volume constant, okay? After drawing a straight line, get the value of these pressures over here. Get the value of these pressures over here. Corresponding to temperature T3, let the pressure be P3 here, let the pressure be P2 here, let the pressure be P1 here. Since, my dear students, I have drawn a straight line, that means I have kept volume constant. N is already constant, R is already constant. So I can say pressure is directly proportional to temperature. Over here, if you look at these parameters, P1, P2, P3, can I say P1 is greater than P2, which is greater than P3? P1 is greater than P2, greater than P3. And we know more the pressure, more the temperature. So more the pressure, more the temperature. So T1 has to be greater than T2, which has to be greater than T3, right? As simple as that. Similarly, if you need to solve this particular equation, again draw a straight line. Since you are drawing a straight line, P is equal to nRT divided by V. Since you are drawing a straight line, that means you are keeping temperature constant. N is constant, R is constant. So pressure is inversely proportional to volume here. So my dear students, get the corresponding volumes over here. Get the corresponding volumes over here. So volume corresponding to pressure P1 is V1, this is V2, this is V3. What about the relation between V1, V2, V3? I can clearly say V3 is greater than V2 is greater than V1. V3 is greater than V2 is greater than V1. And you know, Pressure and volume, they are inversely proportional. So more the volume, lesser the pressure. So I'll say P3 will be less than P2, will be less than P1. This is going to be the order of the pressures over here. Perfect. And this is the similar sort of question. And I believe you can easily solve this one as well. Okay. And do let me know its answer in the comment section of the video. Now, one more important question, which is almost every year asked. Examples of extensive properties, examples of intensive properties. My dear students, all these examples are basically the examples of extensive properties. Anything can be asked. And all these are basically the examples of intensive properties. Anything can be asked out of these as well. So remember these extensive and intensive property examples directly because they are asked in your examination. And the session PDF of this particular session I'll be sharing on my Telegram. The name of the Telegram channel is Wassim Bhat Chemistry Official. For all those students, Wassim Bhat Chemistry Official is the name of the Telegram channel on which I shall be sharing the handwritten PDF of this particular session as well. Okay, right? So you guys can join that particular Telegram channel to know more about all these things. All right, one more important question. That is question based on ideal solution or non-ideal solution showing positive deviation, non-ideal solution showing negative deviation. My dear students, directly right now remember few points. In case of ideal solution, delta H mixing is 0, delta V mixing is 0, delta S mixing is positive, delta G mixing is negative. And these are the examples of the ideal solutions. Toluene benzene, C2H55, C2H5Br, N-heptane, N-hexane. Non-ideal solution showing positive deviation. Delta H mixing positive, delta V mixing positive, delta S mixing positive, delta G mixing negative, right? And remember, non-ideal solution showing positive deviation, they form minimum boiling azeotrophs, and these are its examples: ethanol acetone, carbon disulfide, and your acetone. Similarly, acetone and benzene. And when I talk about non-ideal solution showing negative deviation, delta H mixing is negative. Similarly, delta V mixing will be negative. Delta S mixing is positive. Delta G mixing is negative. And they form maximum boiling azeotrophs. And my dear students, these are its examples as well. Phenol and aniline, they make this kind of the solution. Chloroform and acetone, even they make this kind of the solution, right? Similarly, a question is asked on solubility and solubility product. My dear students, for example, this is a sparingly soluble salt, right? Let its solubility is S. If it is solubility is S, I'll say concentration of A positive will be S, concentration of B negative will be S. How do you write KSP expression? Concentration of A positive raised by its stoichiometric coefficient multiplied by concentration of B negative raised by its stoichiometric coefficient. So KSP will be equal. Concentration of A positive is S, concentration of B negative is also S. So S multiplied by S makes it S square. So you can calculate S value from here, which will be root of KSP. In general, let's say you have got the sparingly soluble salt as AXBY. This is how it undergoes dissociation first of all. If the solubility of this salt is S, so concentration of AY positive will be X times S. This will be Y times S. Now, when you write the KSP expression, you get the final KSP result over here like this. Okay. Now, what kind of question is asked from this? A basic question, my dear students, is asked. A basic question is asked. For example, you have got a question wherein, my dear students, the KSP of MgOH whole twice is given to us. KSP of MgOH whole twice is given to us, which is 3.2 into 10 raised power minus 23. This is the KSP of MgOH whole twice. First of all, how this MgOH whole twice undergoes dissociation? Mg di positive plus 2 times OH negative. If it is solubility is S, its concentration is going to be S and its concentration is going to be 2 times S because the stoichiometric coefficient here is 2, here it is 1. Now, when you write KSP expression, it's going to be concentration of Mg di positive, that's S, concentration of OH negative raised power 2. So KSP value comes out to be 4S cube, or S value comes out to be KSP divided by 4. And KSP in the question is given to me as 3.2 into 10 raised power minus 23 divided by 4 whole raised power 1 by 3, which comes out to be 0.8 into 10 raised power minus 23 whole raised power 1 by 3, which is going to be 8 into 10 raised power minus 24 whole raised power 1 by 3, right? Which comes out to be 2 into 10 raised power minus 8 moles per liter over here, right? So this is the value of solubility which I was supposed to calculate, and this is how, when KSP is given, you're supposed to calculate solubility. This is how you do it. Now, my dear students, if the stoichiometry changes here, all this process is going to change. If it is 1:1 stoichiometry, then KSP comes out to be S square. So S is simply going to be equal to root of KSP. Okay. This is one more frequently asked question, right? Which is almost asked every year in your exam. One more question based on your delta G, Gibbs free energy. My dear students, there is a question asked wherein you have to check at what temperature the process is going to be spontaneous. Now, first of all, you should know for any process to be spontaneous, delta G for the system at constant pressure temperature, it has to be negative. And delta G means delta H minus T delta S. For example, you have got a question. A reaction is given, a process is given, its delta H is given, delta S is given. Calculate the temperature above which the process is spontaneous. Now we know for the process to be spontaneous, delta G has to be negative. That means delta H minus T delta S, it has to be negative. What is delta H? 80 kilojoules. That means 80,000 joules minus temperature multiplied by delta S is 2 times T, which comes out to be 2T square here simply. It comes out to be 2T square. This has to be less than 0. So I'll say 80,000 has to be less than 2T square, or you can say 2T square is greater than 80,000 here. So my dear students, you can say T square should be greater than 40,000, and if T square is greater than 40,000, that means T has to be greater than 200 Kelvin, right? So the temperature has to be kept greater than 200 Kelvin, then only this particular process is going to be spontaneous. This is a short question which is almost asked every year in your examination, wherein you have to check the temperature above or below which the reaction is going to be spontaneous. And you should know for any process to be spontaneous, delta G for the system has to be negative at constant pressure and temperature. That's all, right? Now, similarly, my dear students, there is one more question which is asked. You'll be given certain compounds and you will have to check whether the compound is behaving like oxidizing agent, whether it's behaving like reducing agent, whether it can behave like oxidizing as well as reducing agent. So for that purpose, what you need to do, whatever compound is given to us, first of all, get the oxidation state of the central atom. Get the oxidation state of the central atom. If the central atom is present in its maximum oxidation state, the compound is going to behave like the oxidizing agent. If the central atom is present in lowest possible oxidation state, it is going to behave like the reducing agent. If the central atom is present in its intermediate state, right, it can behave oxidizing as well as reducing agent. And these compounds, wherein the central atom is going to be present in the intermediate state, these sort of compounds also undergo disproportionation as well. For example, I need to check whether this compound is oxidizing agent or reducing agent. How do I check it? Get the oxidation state of phosphorus. Phosphorus here is in +5 oxidation state, and +5 is the maximum oxidation state which phosphorus shows. So central atom is present in maximum oxidation state, so it's going to behave like the oxidizing agent, right? Talk about sulfur. Sulfur is in +4 oxidation state. Sulfur here is in +4 oxidation state, which is the intermediate oxidation state of sulfur, right? It can increase as well as decrease its oxidation state. If sulfur is present in intermediate oxidation state, it can behave like oxidizing agent as well as reducing agent. H2O2. Oxygen here is in -1 oxidation state, right? Oxygen here is in -1 oxidation state. So again, oxygen is present in intermediate oxidation state. It can increase as well as decrease its oxidation state. So it has got the dual nature. It is going to behave both like oxidizing as well as the reducing agent, right? Now, my dear students, one last thing, that is experimental determination of the order. This again one frequently asked question in your NEET examination. My dear students, whenever you are given with this sort of a question and you are supposed to calculate order of the reaction, and some experiments are given. First of all, get the rate law. R is going to be K, concentration of NO raised power X, concentration of Cl2 raised power Y. Okay, so basically you are supposed to get the value of X, you are supposed to get the value of Y. Without even solving the question, you can get the answer. How exactly? My dear students, if you look at experiment 1 and experiment 2, in experiment 1 and 2, concentration of NO is kept same and concentration of Cl2 is increased 3 times, and look at the value of rate is also increased 3 times. So basically, when Cl2 concentration is increased 3 times, rate is increasing 3 times. That means the power of Cl2 here is going to be Y. Then only 3 raised power 1 will come out to be 3. So Y value is directly coming out to be 1. Simple case, right? Y you got. Now, if you look at experiment number 1 and experiment number 3, in 1 and 3, Cl2 concentration is kept same. What is happening to the concentration of NO? Concentration of NO is increasing 3 times. And if concentration of NO is increasing 3 times, what is happening to the rate? Rate is increasing 9 times. Initially, it was 1 in 10 raised power minus 3. Now it is 9 in 10 raised power minus 3. So on increasing the concentration of NO 3 times, on increasing this 3 times, rate is becoming 9 times, which is only possible if the power here comes out to be 2, then only 3 ka square comes out to be 9. So you are getting the X value here as 2. If you got the Y, you got the X. Overall order of the reaction is X plus Y. That means the overall order of the reaction is going to be 3 over here. My dear students, these are some some 9 to 10 concepts which I have discussed in very lesser time. So please and please do watch these sessions. I am giving you 100% assurance that questions will be coming from these small sessions for sure in your upcoming NEET